Okay, and let's delete curve. Again, delete curve, delete curve. Let's compare 3A, special history, 3A, now CO2 trap. It's like this. Compare it to structural only, okay, and structural plus hysteresis. Okay, so now we can understand what is CO2 trap. CO2 trap, actually CO2 trap because of hysteresis trapping, right? CO2 trap as CO2 residual CO2 being trapped in the pores by the hysteresis effect, by the, critical gas saturation effect. You have the least CO2 trap because in structural trapping only, because you see we have low critical gas saturation, which makes more and more CO2 being escaped from the pores as it propagates farther and farther from the well. As we increase the hysteresis effect, now critical gas saturation or residual gas saturation becomes higher. It means more and more CO2 being trapped in the pore spaces because of capillary effect or hysteresis effect. Okay? Actually, hysteresis plus solubility supposed to have, the same amount of CO2 trap. But why we have less CO2 trap here? Yes, again, because now we have CO2 moves into the water. Yes, first CO2 trap in the pores, in the pore spaces, but it will not stay there as being trapped in the pore spaces. It will be dissolved into the water instead of staying on the pore spaces as residual CO2. So that's why you have less CO2 trap in the case of solubility trapping than in the case of hysteresis without solubility trapping. Okay, so it's, very, very interesting. Maybe lastly, profile. What can we see here? Let's see. Well, 3A, CO2 injector, gas mass density. Oh, now we have to move across time. Let's see at the end. Okay, so it's like this. Okay. All right. The horizontal axis is the gas mass density, and this is the distance. Okay, so far so good, and I think we can call it a day. So we have discussed about solubility trapping. We have modified the model, the aquifer model, and then we have modified the fluid model, and then we run the simulation and visualize the results using, using results, which is very, very, very interesting. And we compare the three cases. And yeah, that's all. In the next video, we will again perform solubility trapping, but we will have different, the diffusion coefficient method. Here, in this case, we have Lingham's method for the Henry's constant, Henry's constant. And on the next video, we will have another method, not from Lingham's method, but Harvey's method. Okay, so that's all. I hope you enjoyed this video. I hope this video is useful. And thank you so much for watching. See you again on the next Eng-Man videos. Thank you.